already done them, and we'll go over those to make sure we have those concepts solid. 13's hard. Those are just hard. You just stick to it, persevere, you'll get there. Excuse me. I thought I had something else. Alrighty, are we ready? 9 and 13, or need another minute on 13? Another minute on 13, okay. I'm afraid that they're doing a homework problem on waiting. Like, just chill. Whatever you want. It's your time. Talk. Are we good? Okay, 9. What'd you get for an answer? 112. Did you communicate your thinking well? That is the correct answer. So afterwards, it's only did you communicate your thinking well? Did you write the big idea first? Did you then find what the inverse is at 0? What is it? 2. Did you communicate what the derivative is? And then you're home free. All right, so that's all the stuff I would look for in a rubric. And then that's obviously the concept and the answer. We good? Okay. You can expect inverses in a lot of ways. I mean, I could layer this on top of lots of different calculus ideas. Can you do a tangent line? Can you find where something's increasing or decreasing? Actually, that would be kind of weird, but lots of different types of stuff could be done with that. No problem. This. So I don't know if you are in the habit of, I had some people in the last class said, yeah, I got into whether this is indeterminate or not, and then I had some people that said, I don't even care if it's indeterminate, I'm just getting a common denominator, and that's the first thing I do. Either one is fine. I typically just say, you know what, I'm just going to get a common denominator, and when you get a common denominator, did you get something like 2x? This is times x minus 1, so minus 3x plus 3, or is that about right? Okay, and so negative x plus 3 over x plus 3x minus 1. Yay? Okay, now, say your direct substitute. Is this a L'Hopital problem or no? The top goes to 6. So right away I can say, no, it's not a L'Hopital problem. So if you took derivatives, you definitely made an error. That's not true. You shouldn't be doing it. It's not L'Hopital appropriate. All right. Say D and E was a multiple choice and it was there. Would you go for it? D and E is a problem. I mean, it is undefined. The limit doesn't exist there. You cannot put negative 3 in. You get a 0 in the denominator. Furthermore, there's vertical asymptote behavior. Is there, remember, a limit at its heart is really is there a numerical y value that is approached? It's infinite. Okay, so the only question is, all right, do they give you that bailout? Is D and E there? Or are the choices only infinity and negative infinity in some bogus things? So let's say it was infinity and negative infinity were there, but not D and E. What would you do? Not L'Hopital, so you're not taking derivatives now. Yeah, you really need to know on on the side they say to approach from, are we talking infinity or negative infinity? So if we're talking -3 from the right, then either way, wouldn't you agree that the top is positive 6-ish either way? Okay. So that's, I'm just going to put 6 down, although it's close to 6, but whatever. It's still positive. What about this guy? Small negative or small positive? Negative. So what should I choose for an example? Negative 2.9 or negative 3.1? Negative 2.9. Okay, so if I take negative 2.9, is this a small positive or small negative? Small positive. Small positive. And I'm talking very small positive as I get closer and closer to. This is negative 4-ish, yeah? Ish. You down? So all said then, I have this negative 3/2 and a small positive. So does this go to positive infinity or negative infinity? Negative. Okay. All right. Today's lesson is really important, a very big one, and I'm only going to do half of it today and teach half on Tuesday. So it should go pretty quick because today's the easy part, the more Saxony part. So I'm here, trapezoidal rule and error bound. Okay, so back in the day, when you first started talking about area under the curve, you used what kind of geometric figure? Rectangle, okay? We said that the sum of many delta x's for the base and f at different points for the height is rectangles, and then we get perfect area by taking the number of rectangles to infinity, yeah? Now, for many, many years, I'm talking thousands of years, from the Greeks to the invention of the calculus, that was what they stayed at. But with the invention of the calculus, and a little physics thrown in, they start to realize that this infinite sum is nothing but the fundamental theorem, where delta x, when we take infinitely many rectangles, delta x gets smaller and smaller and becomes this more theoretical exercise, infinitesimally small dx, yeah? That's how we find the area under a curve perfectly. Works great. Rectangles are logical. Rectangles are what's taught first because that's what the fundamental theorem comes from. However, if you were to think of a curve like this, except it's a function, rectangles kind of stink because here is fine, but wouldn't you agree that when the y values change a lot, then I start to get a lot of error introduced by using rectangles? It'd be a heck of a lot better if in this subinterval, instead of using a rectangle, I use something that followed the curve a little better, like that, which would use a trapezoid. So instead of all this error, it's only a little bit of error, yeah? So trapezoids are far superior in terms of estimating the area under the curve. So far, so good? Okay. Now, the next logical question is, why estimate it at all? If we have the fundamental theorem, why don't we can integrate it and call it good? Get the exact. Well, because not everything can be integrated. Not everything has an antiderivative. I mean, I could ask the Fields medal winner what the antiderivative is, and he can look at it all day, And it doesn't have one. There is no antiderivative to this. There is nothing that yields that as a derivative. Nothing. Not everything can be integrated. So in those cases then, you still have to find the area under the curve. What do? Well, you use an estimation, like trapezoids. Okay? So in those cases, we will use trapezoids because they're superior. Now, it goes a little like this. This is a big space, and I'm going to show a lot of steps, but it's going to work towards more of a shortcutty kind of thing. So this will be one time only. This bunch of notes. You with me? All right. So let's say that the eraser's in the wrong spot. Let's say that this curve looks something like, I don't know. I'm sure it oscillates like crazy, but who cares? Just do this, okay? It doesn't have to be perfect. It just has to be something I can explain from. So we're talking the region from 0 to 12, and we're going to break it up into 4 trapezoids of equal subdivisions. We will do unequal subdivisions later. That's more of an AP style. The Saxon problems are usual equal subdivisions. It's probably pretty obvious, but what's the delta x? It is what? 3. Yeah, how'd you do that, just for the record? 12 minus 0 over 4. And wouldn't you say it's the total region divided by the number of trapezoids? Okay. So in this case, delta x is 3. So I'm going to go 0 to 3, 3 to 6, 6 to 9, and then to 12. All right. Now, the trapezoids are a little misleading in that we're just always thinking of trapezoids as having the parallels on the horizontal, right? In these cases, the trapezoids will always have vertical, not always actually, I shouldn't say, but usually have vertical parallels. And the base will be here. So these, the heights are vertical, or sorry, the bases are vertical. And the height is horizontal. No big deal. It's just turning a trapezoid on its side, if you would. So don't sweat it too much. All right. So, can we say then that the first trapezoid is, we know it's base 1 plus base 2 times height divided by 2. And what is base 1? F at 0. And what's base 2? F at 3. What's the height? 3 divided by 2. Remember, the height is the horizontal axis distance. Cool? All right, the second one, I'm not going to write the formula every time. That's a waste of my time. The trapezoid from 3 to 6. It looks like that. So what's base 1 and base 2? F at 3 and F at 6 times what height? Divided by 2. Okay, third trapezoid. Bases? F at 6 and F at 9 times 3 divided by 2. And the last, F at 12 times 3 divided by 2. All right, now working towards a shortcut, which is delightful. Greatest common factor. What's the greatest common factor? They all have a 3 and they all have the over 2. Yeah? Okay. Now once these guys are removed, and if I drop the brackets, separating them, combine like terms. How many F of zeros are there? Why only one F of 0? Yeah, there's only one place where we use the 0. But how many F of 3s? 2 F of 3s, and that's by virtue of being base 2 of the first trapezoid, but base 1 in the second trapezoid. Yeah? 2 F at 6, 2 F at 9, and what about F at 12? Does it have a buddy or all of them? All right. So you can see that all the interior x's happen twice. The exterior is only once. So the shortcut, if you would, we could put that in our calculator and get an estimate, but let's not waste our time. You with me? Okay, so the shortcut, if you will, is to factor out the height and the divided by 2, remembering again that height is delta x. I know it's so hard to think of height as going horizontally, but the height is the delta x, factoring out the half, because they all have that part of the function, the formula, and they all have the same height. And then it's just a single exterior and double all the interiors. Are we cool? Okay, so with that said, try this one on your own. You do not have to do all that separate trapezoid work. You can go straight to the factored out, greatest common factor, double interior values. Let's see. How bad is it? Throw it in your calculator. Yes, we could do it by calculator. Okay, while you're finishing, what's the height of each trapezoid? What's the height of each trapezoid? 1. Okay, if you take a region that's 3 wide, divide it into 3 chunks, each one is 1 wide, but that width is really the height of the trapezoid. Each side is the perpendicular distance between the parallels. Okay, if I let f of x equal this interior function, then the inside is f at 1 plus 2f at 2's, 2f at 3, sorry I made a mess of that, and a single f at 4, yeah? So did you get something like 4 plus 8 plus 2 over 9 plus 27? That's not much fun. 1 over 16 plus 64. What did you get for an answer? Anybody? 0.367. Okay. That is an estimate, surely on the AP test on a free response when you use the trapezoid method, which is the most common. If you say it's equal to on an estimate, you're out of luck. All right. Would you look at this multiple choice? Which of these choices represents the trapezoidal approximation of that our integral? Okay, so what's out front? Nothing or one, I guess? 1/2 or 1/4? 1/4. Remember what's factored out front is the half from the formula and the delta x for the height, and that means 1/4. So A, B, and C are all gone. It's down to D and E. How do you choose between D and E? It is E because of the 2 pattern. It's the 1, 2, 2, 1 pattern. So it is E. Did we get it? Okay. That is that. I don't have extra practice yet. The extra practice is on Tuesday. So you should be good for most of the homework. The homework is due Tuesday. If you get a problem that says 95, you're not quite sure how to do it, it might be because I haven't taught the airbound yet. Just skip it and leave it blank. Okay. So do you want to go over questions on the fun sheet, or you want to talk practice for the test? What do you want to do? Sheet first. The answers to the fun sheet are on my website in a kind of a weird place, but under the day in the calendar. So hopefully it's good. All right. So I heard a little mixture of everything. If you would like, if you just on the fun sheet, would you come in 7th period? It's easier to go over it individually. I want the fun sheet tomorrow, before you leave tomorrow, so I can grade them over the weekend. Understood? Okay, so if it's done today and you got them all right, by all means just turn it in. You obviously understand it just fine. But working towards the test, so I would strongly suggest you study, if you're going to study sets 88 through 92, the notes/big ideas, and the problem sets, because I will be pulling problems from the problem sets. I want to reward the people that do homework well, and hopefully punish the people that don't do homework well. We'll see. So, should we start at the oldest or the newest? Oldest. Okay. So, let's go with 88. 88 is differential equations. First and foremost, the vocabulary. When I say solve a differential equation, what does that mean? Okay. Yes. Yes. When I say solve a differential equation, what do? Separate the variables and integrate. You're trying to get the original, the goal is the original yx equation. Okay, cool. Second, if I say what's the general solution, what does that mean? Yeah, no, it's just no finding the c, you leave it as plus c. If I say what's the particular solution, that then is find the c. If I say solve for y equals f of x, the particular solution, that means solve for y. You're going to find c, find c, solve for y, and make sure your answer is a function, not any plus or minus. Would you like to try to practice one of those real quick? Or no, you got that? Those are good. Okay. Next, a subset of those differential equations. Make sure you can do set 88 fun sheet. There are a lot of AP style practice problems on there, in addition to the actual set 88. Next, the most famous differential equation. If I just said, give me the verbal statement for the differential equation for exponential growth. Go. What is the verbal statement of the differential equation for exponential growth? The amount grows at a rate proportional to the amount. Okay, if I were to say, write that in calculus. The ADT, the amount grows at a rate of A, proportionality constant times the amount itself. This then, when solved for, yields the exponential growth equation. By the way, you'll often see this written a lot of different ways. The y dt equals ky, or y prime equals ky. Then they'll try and do a little gotcha once in a while. What about d x dt equals ky? Is that exponential growth? It is not. Okay. It is something else entirely. So make sure that there is basically the amount grows at a rate proportional to the amount. For this to be differential equation for exponential growth, it's got to be there. All right. Set 89. 89. Oops. 89 was a lot of problems there. Average value. Average value, first of all, can you basic level find average value? If I said find the average value of some function x cubed plus, let's go this, on 0 to 2 with calculator. Did you do it? Okay, what would you do? 1 over b minus a, so 1 over 2 minus 0 from 0 to 2 of x cubed plus hyperbolic secant, and you'd slap it on the calculator, and you'd do more, or just circle your answer.
How do you do such?
So you choose, so we would do something like, I can't remember what it was, 1/2, 1 divided by 2, shift plus 0 to 2, sorry, might as well do it all. What was it again? X cubed. So now, finally to your answer. You say, in the trig menu, you choose secant, except not in the exponent of the x cubed, plus, so you just choose secant and then you add in an h. So you scroll back over and say h, and then, I hope this is defined. I don't actually remember what the domain of hyperbolic secant is, but we'll see. Okay, boom, and I get 2.650. Satisfactory? Okay, cool. Second is applications thereof. So if I said a ball is thrown up at 5 feet per second from a height of 500 feet, is that clean? I'm going to say 16 feet per second from a height of 576 feet. What is the average velocity? Well, it's in the air. We've done stuff like that. Would you know what to do? You want to walk through it, or do a walkthrough, or no? You're good.
You're looking pretty good.
You good? Okay. All right.
You want it?
Step 3 then is the mean value theorem for integrals. What if I said find the C guaranteed by the mean value theorem for integrals of f of x equal x squared plus 2x plus 1 on 0 to 5. Let's go smaller, 0 to 1. Did you do that? Okay? First thing I would recommend by looking at maybe about a fourth of you, I would strongly suggest you underline this word, because if I see this, the minute I see that symbol, you're toast. You have no idea what you're doing. Okay, you are obviously thinking mean value theorem for derivatives, all right? Furthermore, if I see a bunch of this, that's just further indication you don't know what you're doing. Just a kind of a general rule of thumb, if it says mean value theorem for integrals, your work should probably have an integral in it. Yeah. So that's a good check, I guess. After you, so does this involve just finding the average value? What else does it involve? Finding the C at which. And am I good if I did this? Would I be rocking and rolling?
Yeah.
You would have lost a point because you didn't meet the. Yes, there's a condition for this. So I feel like maybe we don't feel like this is as hard as this. You think you're good, but you have been doing it wrong. Is there a condition? Yeah. It must be continuous. F is continuous. So there is a C in. Now, what if I solve this and get two answers? Yes, sir.
So if you say differentiable just to get C,
Covering your butt, you don't know what you're doing. That's not a condition.
so you get marked off.
No, yeah. I mean, it would be like saying F is continuous and its domain is all reals and it's got a number in it, and you could throw all the crap in the world on it, and you're implying that all that stuff is necessary, and it's not. What you say it should be what's necessary, and that's all, and only that. It's like those people it's like my AB students that are doing they don't know the difference between the first and second derivative test. And they'll say, just give me some kind of Frankenstein to cover their butt. There's a max because F prime goes positive to negative, and F prime is 0, and F double is negative. You don't know. I said use the second derivative test, and you're just basically spitballing, throwing a bunch of crap out, shotgunning it, and hoping something sticks. Tell me what needs to be said and nothing more. Okay? This could have two solutions. Would you choose both? You would only choose the one within the domain. Okay. Set 89 then, and lots of possible applications, lots of possible AP problems there. I don't think I did an extra practice there. I think it was just the problem set. By the way, as I grade all these problem sets, I constantly mark which ones I graded and which ones were disastrous, and I made notes. A lot of people said this, or a lot of people blew off that. Those are the problems I'll be choosing from. The ones that were done badly on the homework. So if you did them right on the homework, then you should be good. If you gave me garbage, then you should be bad. All right. Set 90. Set 90 is distance. It's actually just motion in general, but particular emphasis on distance without a calculator. Okay. So if I give you position, t squared plus 4t minus 1, and I say find the distance traveled on 0 to let's go, yeah, that's fine, 0 to 3, would you be good there? What would you do? Take the derivative. Okay, so 2t plus 4, great. Oh, can I make this minus 4 so it's more interesting? Okay, so you say you do an integral, okay.
Well, you have to do that. You kind of see. So you got to do the.
Okay, so we need to draw this in a piecewise way, or at least find out when it's moving in a right or left kind of way, because distance is the absolute value integral. I need to know what part is being flipped and what part isn't, yeah? You could just kind of do this in a sign charty way, or if you know the graph, you could graph it. Isn't 2t minus 4 something like this, but the absolute value flips it like that, yeah? Okay, so what are the pieces that I need to integrate? From 0 to 2, I use v or negative v? Negative v, and then 2 to 3, I use normal v, okay. Then what?
X.
Negative x at from 0 to 2, and x from 2 to 3, yay? And then I continue on from there. Negative x at 2 plus x at 0. Plus x at 3 plus x at 2. Okay. Find those. Call it good. Yay? Alrighty. Had a lot of we had some of those where the integrals were pretty gross. For the most part, people integrated stuff like this well. Distance on 0 to 2, 3. All I would say is make sure you integrate well, and you should be good, yeah? Whether you use sub or meant to use sub. Okay, and then 91. Oops. 91 is two indeterminate forms. What are the indeterminate forms of 91? Alrighty then. Okay. So if I just wanted to reward somebody for studying, then I'd say, what are the two indeterminate forms of 91? Infinity minus infinity and infinity times 0. Yeah. All right. Now those are all approaching 0. Okay, cool. So these are indeterminate forms, and you use L'Hopital, but can we use L'Hopital when they're in this form? So, for example, tangent of, no, I guess I want this to go to 0. Tangent of x times log of x. What would you do? Tangent of the denominator. Okay. Never take derivatives until it's a quotient, so cotangent pair, yeah? Okay, then what? Then you should probably think, hey, now I should do some L'Hopital work. So, what does log of x go to? Negative infinity. What does cotangent go to? Positive infinity. So it sounds like we're a little rusty there. And that is an indeterminate form, yay? So limit as x goes to 0 of, by L'Hopital, 1 over x over, what's the derivative of cotangent? Negative cosecant squared. I definitely don't want to play with that, so I'm going to clean it up. Isn't that negative sine squared? Yeah, negative sine squared in the numerator, yeah? Okay, cool. What do I get now? You get something that's still indeterminate, so do it again. Limit as you still don't cut corners, you still do things the right way. Negative sine squared goes to 0, x goes to 0, so by L'Hopital again, the limit as x goes to 0 of negative 2 sine cosine over 1. So our answer is all that for 0. 0 is pretty important, actually. Okay. That's 91. On these, make sure usually you get a common denominator. Make it 1. All right, that's 91. And 92, sounds like you had a feel for 92 is derivatives of inverses. We did them in an equation form. Could you do them in a table or a graph like we did in the notes? Are we all good there? Okay. Bene, sounds like we're on our way. Oh, and hyperbolic trig, sorry. Hyperbolic trig, you're good. Sinh is plus or minus? Minus, and cos is plus. If you know that, that's at least a good start. Okay. Have a good day. Oi.